Hello everyone and welcome to Programming for Beginners, episode 4. In the previous episode, we discovered the concept of class in object-oriented programming. We know that a class can have fields, methods, and that it serves as a blueprint for creating objects. It is the object that we work with, not the class. All these might be a little confusing right now, but don't worry, everything will make sense once we see more examples. In this episode, we'll look at properties and inheritance. Let's start with properties because they are very easy, and they are very easy because they are like methods. Let me give you an example. Suppose we are here, inside the increaseTextSize method of our car class, and we want to know what is the font size of the acceleration button before calling its makeTextBigger method. Maybe the font size is already big enough and we don't even need to make text bigger. So we have two ways to get the font size. We could either make the field public, so it can be accessed even from outside the class, like this. And here we create a local variable that stores a number, int. Let's name it size. And size takes the value of the font size field from our acceleration button. This is one way to get the font size, but it is not ideal, and here is why. Being able to access the font size directly means that we could also change it. So we could make the acceleration button font size 1000. Now, imagine that someone is blindfolded and someone else feeds him potatoes. But what if that person is allergic to potatoes? Same thing with our button. Imagine that for some reason the button doesn't like or can't even display such a big text. So allowing others to change its font size to any value is a bad idea. And this brings us to the second way to access the field, by using a method, because we know methods can return one value and can receive multiple values called parameters. So here, inside the button, we can add a public method which should return a number, int. Let's name this method getFontSize, with no parameters. And the only thing this method needs to do is to return the font size. Now we can make the font size private again, because we only use it inside the button class. This error is expected now, but we will fix it by calling our new method instead. And in order to get rid of this error, we need another method that can change the value of the font size. So back to the button, we add another public method which doesn't need to return anything, so we make it void. Name it setFontSize. It takes only one parameter, a number named newSize, which we use to set the font size field, like this. The advantage of having this method is that the button can decide based on its reasons if the font size should take this new value or not. So, for example, only if the new size is less than 200, it is okay for the font size to change. And now we can get rid of the last error by using the setFontSize method. As you can see, makeTextBigger and setFontSize are very similar. The only difference is that makeTextBigger also returns a value, its purpose being to confirm whether the value of the font size was changed or not. And now let's see what properties are. I'll first write one property and then we'll look at it. So it is like a public method which can return one number and can also receive one number. Its name, although you can give any name to a property, doesn't need to contain the get and set like these methods, because we should see properties more like values or fields, more like a storage, unlike methods which we should create with the purpose of doing some action. Hence the get and set, which are verbs, they describe an action. So with only one property, we combined the functionality of two methods, getFontSize and setFontSize, which means we don't need them anymore. And here, instead of those methods, we can use the font size property. What happens is, in this context, the get part of the property is used, and in this context, where we need to change its value, the set part is called. The content of the get and set is identical to the content of the get and set font size methods we just deleted. Let's see now what inheritance is. The easiest way to understand it is again to take a real-world example. We have our car class here, and it can accelerate from 0 to 100 when we call its accelerate method. What if we want, instead of this car, to have a faster car which accelerates from 0 to 200? Of course, we could do this by adding a parameter to the accelerate method like this, int speed, and the current speed takes the value of this parameter. But we can achieve the same result by using inheritance. Inheritance works like this. Say we have a good recipe for a chocolate cake and we are happy with it, everybody loves it. We keep this recipe in the kitchen printed on a piece of paper. One day we decide to change it a little and make a white chocolate cake. For that, we could copy the original recipe on a new piece of paper, changing only 1 or 2 ingredients. But we would waste a lot of time and space. We have to store 2 recipes now. And what if we make a mistake on copying? Or if at some point we decide to change the amount of baking soda, which is a common ingredient, we have to change it in 2 places. So, a better way to do this is to make the changes on the original recipe, making sure we still see the original ingredients, of course. It is the same with inheritance. It saves time, space, and prevents copy-paste errors because there is no copy-paste. So let's create the recipe for our fast car. Class fast car inherits from car. At this point, car and fast car are exactly the same. But since the purpose of the fast car was to accelerate to a higher speed, let's change only what we need, the accelerate method. The way we do this is by making the method virtual in the parent class and adding the keyword override in the new definition. And here we set the current speed to 200. One more change. We need to change the protection level of the current speed field from private to protected. And now current speed can be accessed from all classes that inherit our car class. Let's apply the inheritance to our button now and see how much it simplifies things. Remember that our button class is inside this namespace, and the button object here is created from a button class which is defined in this namespace. Let's see what happens if we make our button to inherit from the system button. The first thing we notice is that the font size property already exists defined in the system button, the parent of our button in this case. So we can safely remove it from here. This doesn't mean that our button doesn't have a font size anymore. It still has a font size, but the code for it is already written inside the system button class. So inheritance saves us time and space because we don't have to write the code that already exists in the parent class. We can also remove the font size field. And here, use the property instead, which is a real number. So we have to change the type of this local field from int to double. Now let's make this button useful. For that, we need to introduce the notion of constructor. Every class has a constructor that looks like this. It is public, has no return type, not even void, and its name is the same as the name of the class. Whatever we write inside this constructor will always be executed once for each new object created from this class. So in our case, when we create the acceleration button object here, the constructor is called. This gives us the chance to do any initialization before the object is used. And one thing we might want to do is to set some default value for the font size. Let's make it 120. But let's not stop here and give some default values for other properties of our button, which are inherited from the parent. And if we look in the main window.xaml file, we can see what other properties we want to change. It's the font family, background, and border. So in the constructor, we can set default values for all these properties. The font family should be set to Bradley Hand ITC font type. But if we set it like this, we get an error, because font family is not a text, it is an object, just like our acceleration button. So we have to use the new keyword to create an object from the font family class. What happens here is that a new object is created, its constructor gets called, and then the object is returned and stored in this font family property. But a constructor can have one or more parameters similar to methods, and in this case, if we retype the first parenthesis, we see this class has 3 constructors, each one taking different parameters. So the one we want to use is the second one, which accepts the name of the font. In our case, Bradley Hand ITC. And this is how we initialize the font type of our button. Let's do the same for background. But since background can store only an object created from the brush class, as we can see here, we have to create a new brush. The error tells us that we cannot use the abstract class brush. If instead we use a solid color brush, which is still a brush because it inherits from the brush class, everything is fine. Other types of brushes are gradient brush or image brushes. This is an example where you can see the utility of inheritance. The brush class contains the code that is common to all brush types, and each brush type, solid, gradient, image, and so on, contains only the code that makes it different. Now, if we look at the constructors of this solid color brush, we see it has 2, and we need the second one because it lets us send it the color we want. And we send the color like this. Because the type of the parameter this constructor accepts is a color object. And this white here is a property of the class color that creates and returns a color object. And finally, the border brush, which is also a brush, can be initialized in the same way. And we make it black. Now, let's return to the game and use our button instead of the system button. So, open the main window.xaml file and add a local in front of each one of these buttons. By doing this, we use the button from our namespace, the button we created, and not the one from the system namespace. Everything works fine because our button inherits from the system button, and additionally sets default values for some properties. This is what makes it different. Now, since our button already assigns these values to its properties, we don't need the style. Let's run the app now and see if our game buttons look the same. Okay, now let's change the border color to red. So we go to our button class and inside its constructor, we set the border brush to red. Hit run again. And we get the red border. So this is how inheritance helps us to take a class, in this case the system button, a class that already has all the code and functionalities we need, inherit from it, and add just the code we need to make it look or behave the way we want. That would be all for this episode. Thank you for watching and feel free to leave your feedback in comments.